The solar system, also known as the Sun system, is a system that contains the Sun and all celestial bodies bound to it by gravity, including 8 official planets, dwarf planets, moons, and countless small objects. The solar system was formed 4.6 billion years ago from the gravitational collapse of a giant molecular cloud. The central part condensed into the Sun, while the rest formed protoplanetary disks and developed into planets and other celestial bodies. The solar system consists of 8 officially recognized planets, but some scientists believe there may be a 9th planet. Let's explore the mysteries of the 8 planets in our solar system. The Sun. At the center of the solar system is the Sun, a giant plasmasphere with an equatorial radius of about 696,000 kilometers, accounting for 99.86% of the total mass of the solar system. The Sun is the most important factor that maintains life on Earth and also determines the orbits of all the planets. Currently, the solar system has 8 planets, 4 terrestrial planets, 2 gas giants, and 2 ice giants. Mercury. The first planet closest to the Sun is Mercury, the smallest and also the planet that moves the fastest in the solar system, orbiting the Sun in only 88 days. Mercury comes from the Roman god Mercury, the messenger god, who often carried messages from the gods, symbolizing speed and flexibility. In the East, Mercury is also called the water star, associated with water in the 5 elements. Mercury can be observed from Earth in the early morning or at dusk, appearing as a bright star near the horizon, but compared to Venus, it is much dimmer. Mercury's orbit has a special resonance. It rotates 3 times on its axis for every 2 orbits around the Sun. Its surface temperature varies greatly. During the day, it can reach 427 degrees Celsius, while at night, it can drop to negative 173 degrees Celsius. Mercury's surface is similar to that of the Moon, with many craters from ancient collisions. This proves that it has experienced strong bombardments from asteroids and comets. Mercury has a very large core, making up about 42% of its volume, while Earth's core is only 17%. Its magnetic field is weak, only about 1% of Earth's, but still enough to protect the planet from solar wind.
Venus. The second planet from the Sun is Venus, also known as the morning star or evening star, because it often appears very bright in the sky after sunset or before sunrise. Venus has a size almost the same as Earth, with a radius of about 6,052 kilometers, making it the planet most similar to Earth in the solar system. However, the environment on Venus is extremely harsh. Venus's atmosphere is composed mainly of carbon dioxide, 96.5%, and nitrogen, 3.5%, with clouds of sulfuric acid, creating a strong greenhouse effect. The atmospheric pressure on Venus is 93 times greater than Earth's, equivalent to the pressure at a depth of 1 kilometer under Earth's oceans. The surface temperature of Venus is about 470 degrees Celsius, making it the hottest planet in the solar system, even hotter than Mercury, which is closer to the Sun. Venus rotates on its axis in the opposite direction compared to most planets in the solar system, meaning the Sun rises in the west and sets in the east. A day on Venus, 243 Earth days, is even longer than a year on Venus, 225 Earth days. Venus also has many volcanoes, lava plains, and high mountains. Scientists believe that in the past, Venus may have had oceans and a climate similar to Earth. But due to the strong greenhouse effect, water evaporated and the planet became dry and hot like today. In 2020, scientists announced the discovery of phosphine gas in the atmosphere of Venus, a substance that on Earth is associated with biological activity, raising the hypothesis that there may be microbial life in the atmosphere of Venus.
Earth, our beloved home of millions of living creatures, including humans, is the third planet from the Sun and the largest terrestrial planet in the solar system. It orbits the Sun at an average distance of about 149,598,834 kilometers. This distance is defined by scientists as one astronomical unit, AU, and is commonly used as a unit of measurement for distances between objects in space. Modern estimates, using radioactive dating and other evidence, show that Earth formed about 4.5 billion years ago. The process of Earth's formation took about 10 to 20 million years. At first, the crust of Earth was molten, then gradually cooled over time to create a solid surface. After that, water began to form and accumulate in the atmosphere. With 71% of Earth's surface covered by water, many theories have been proposed to answer the question, where did water come from? Some theories suggest Earth's water came from icy bodies colliding with Earth, with the ice melting and accumulating into oceans. Other theories suggest water came from underground reservoirs of Earth formed at the beginning, later released to the surface. Until now, there is still no definitive evidence for either, so the question, where did Earth's water come from, remains a great scientific mystery. As we know, Earth is in the Sun's habitable zone. More importantly, it has an atmosphere suitable for water to exist in liquid form, a key condition for the development of life. The boundary of Earth's atmosphere is not clearly defined. It gradually becomes thinner and fades into space. Most of the atmosphere's mass lies within 11 kilometers from the surface, called the troposphere. This region contains about 3/4 of the total atmospheric mass. Here, solar energy heats the gases and Earth's surface, causing expansion of air and atmospheric circulation. This plays a major role in forming weather and climate by distributing heat energy. In addition, Earth rotates on its axis with a tilt of 23.4 degrees relative to its orbital plane. Because of this tilt, the amount of sunlight hitting Earth's surface changes at different positions, creating seasonal climate changes at different latitudes. At the poles, extreme climates occur, with 6 continuous months of daylight followed by 6 continuous months of darkness. These phenomena are opposite between the two poles. When the North Pole has daylight, the South Pole has darkness, and vice versa. It must be said that Earth is a very special planet. It seems to have just the right conditions for life to develop, from the right distance from the Sun to the presence of the Moon stabilizing the axial tilt, and more. This just right combination makes Earth an ideal place for life to flourish. However, as human industry advances, nature suffers damage. From industrial waste to air pollution, these erode Earth's resilience. If humanity does not find timely solutions, one day Earth may react harshly, and the consequences will be unpredictable. That is why we must join hands to protect Earth. Even the smallest actions today will help Earth have a greener, cleaner, and more beautiful environment. Mars. Mars is the fourth planet from the Sun. It is also known as the Red Planet. Although scientists have sent dozens of spacecraft to explore Mars, it still holds many mysteries that humans have not yet uncovered. The red color of Mars comes from the abundance of iron oxide on its surface. It is a small rocky planet with an average radius of about 3,389.5 kilometers. Mars is known to have a very thin atmosphere. On its surface, there are impact craters similar to those on the Moon, as well as volcanoes, valleys, deserts, and polar ice caps, features that resemble those on Earth. Because of these similarities, scientists have long hoped that Mars could one day become a destination for human migration. Mars orbits the Sun at an average distance of 1.523 AU, equivalent to 227,939,200 kilometers. At this distance, Mars takes about 687 Earth days to complete one orbit. This means that 1 year on Mars equals about 1.88 Earth years. A day on Mars is only slightly longer than a day on Earth. Calculations show that it takes Mars 24 hours, 39 minutes, and 35.24 seconds to complete one rotation on its axis, just a bit longer than Earth's 24-hour day. In 1965, when the Mariner 4 spacecraft first flew by Mars, there was much speculation about the presence of liquid water on its surface. At that time, dark streaks appeared at polar latitudes. At first, these were thought to be canal systems containing liquid water. Later, they were explained as optical illusions. To this day, with more probes sent to study Mars, we know that the lack of a magnetic field and its extremely thin atmosphere make the existence of life difficult. The planet cannot retain heat, has no magnetosphere to protect against the solar wind, and its air pressure is not enough to keep water in liquid form. Instead, water on Mars always sublimates directly into vapor. Because of this, Mars is considered geologically dead. Therefore, it is very difficult for life to exist on the red planet. However, that has not stopped scientists from dreaming. Some theorists have put forward ambitious projects to terraform Mars to make the planet habitable again. This may sound crazy, but perhaps in the not-so-distant future, such bold plans could become reality. If that day comes, Mars might become one of the most fascinating tourist destinations for humanity.
Jupiter is the largest planet in the solar system. It is so massive that its mass is about 2.5 times the combined mass of all the other planets. Jupiter is a gas giant, named after the most important god, Jupiter. One of its most striking features is the Great Red Spot, a gigantic storm that has existed for about 340 years. At its peak, the storm was large enough to fit 3 Earth-sized planets inside. The Great Red Spot is oval-shaped, rotates counterclockwise, and has a cycle of about 6 Earth days. Its highest clouds rise about 8 kilometers above the surrounding cloud tops. Jupiter is the only planet whose center of mass with the Sun lies outside the Sun's volume. This means that both Jupiter and the Sun orbit around a barycenter located just outside the Sun's surface, a testament to Jupiter's immense gravitational influence. Jupiter is about 778.517 million kilometers from the Sun, or 5.2 AU.
At this distance, it takes Jupiter 11.85 Earth years to complete one orbit. Jupiter also holds another record. It has the fastest rotation of any planet in the solar system. Despite being the largest planet, it completes one rotation in just 9.9 hours. This means a day on Jupiter lasts only about 9.9 Earth hours. Because of this rapid rotation, Jupiter has an oblate shape. Its equatorial radius is about 4,600 kilometers larger than its polar radius. When observed from Earth, Jupiter has an apparent magnitude between -2.94 and -1.66, making it the third brightest object in the night sky after the Moon and Venus. Jupiter's atmosphere is mostly composed of hydrogen and helium, with small amounts of methane, ammonia, hydrogen sulfide, and water. Its atmosphere lacks a clear boundary and gradually transitions into liquid layers deeper inside. The atmosphere is divided into layers: the troposphere, stratosphere, thermosphere, and exosphere, each with different temperature characteristics. Of course, being a gas giant, Jupiter is not a candidate for life, but its role in the solar system is profound. It acts as a gravitational shield, protecting Earth and the inner planets by capturing or deflecting many asteroids and comets that could otherwise strike them.
Saturn is the sixth planet from the Sun. It is also a gas giant without a solid surface. Its rapid rotation causes it to take on an oblate spheroid shape, bulging at the equator and flattening at the poles. The difference between the polar and equatorial diameters is about 10%. A day on Saturn is very short. Scientists agree that Saturn completes one rotation in just 10 hours, 32 minutes, and 35 seconds. In contrast, its orbital motion around the Sun is very slow. One Saturnian year equals about 10,759 Earth days, or roughly 29.55 Earth years. Saturn has the lowest density of all planets in the solar system. Its average density is only about 0.69 grams per cubic centimeter. This means that if there were a giant ocean large enough, Saturn would float on its surface. At first glance, Saturn is easily recognizable thanks to its rings, the most extensive ring system in the solar system. These rings contain countless small particles ranging in size from micrometers to meters, orbiting Saturn like a giant disk of dust and ice. Most ring particles are made of water ice, mixed with dust and other chemicals. Since Galileo first observed Saturn's rings in 1610 with his homemade telescope, scientists have continued to study them through powerful ground-based observatories and space telescopes. We now know Saturn's rings are extremely complex. They are divided into separate regions named B, C, B, A, F, G, and E, extending from about 6,630 kilometers above Saturn's surface out to 120,700 kilometers. Although wide in diameter, the rings are surprisingly thin. Their average thickness is only about 20 meters. The material ranges from tiny dust particles to icy chunks up to 10 meters across. About 93% of the ring's composition is water ice, with the rest made of amorphous carbon. There are two main theories about their origin. One suggests the rings are remnants of a moon that was destroyed.
The other suggests they are leftover material from Saturn's formation. In the past, many scientists believed the rings formed billions of years ago along with Saturn. But more recent studies suggest the rings may be much younger, only a few 100 million years old. Therefore, the true origin of Saturn's rings remains one of the great mysteries of the solar system.
Uranus. Uranus is the seventh planet from the Sun. It was first discovered by astronomer William Herschel on March 13, 1781. Although Uranus is not often mentioned as much as other planets, it has unique features unseen anywhere else in the solar system. The distance from Uranus to the Sun is about 2.87 billion kilometers. Because of this, sunlight takes about 3 hours to reach the planet. Like the other gas giants, Uranus has a system of rings, a magnetic field, and many natural moons. What makes Uranus stand out is its unusual axial tilt. Its axis is tilted so much that it almost lies parallel to its orbital plane. This means its north and south poles are located near its equator compared to other planets. In 1986, images from the Voyager 2 spacecraft show Uranus appearing as a nearly uniform bluish-green planet without the visible cloud bands found on other gas giants. However, ground-based observations later revealed signs of seasonal changes and increased weather activity, especially as Uranus approached equinox. Wind speeds on Uranus can reach up to 250 meters per second, or about 900 kilometers per hour. Because Uranus is so far from the Sun, its orbital period is extremely long. It takes about 84.32 Earth years to complete one orbit. This means one Uranian year is equal to about 84.32 Earth years. In terms of size, Uranus is the third largest in radius and the fourth largest in mass among the planets.
Uranus has a faint corona that extends outward beyond twice its planetary radius. Scientists divide its atmosphere into three main layers: the troposphere, stratosphere, and thermosphere. Observations suggest Uranus's corona extends from about 4,000 kilometers to 50,000 kilometers above the planet's surface. Unlike other planets, Uranus lacks a mesosphere. Voyager 2 detected only 10 clouds on Uranus in 1986. This relative calm is likely due to the planet's unusually low internal heat compared to other giant planets. The coldest temperature ever recorded in its troposphere was -224 degrees Celsius, making Uranus the coldest planet in the solar system, colder even than Neptune, despite Neptune being farther from the Sun. Some scientists believe Uranus may have suffered a massive collision in the past with a large protoplanet, stripping away much of its primordial internal heat and leaving its interior cold. Another theory suggests a layer within Uranus's atmosphere traps internal heat, preventing it from escaping into space. The extreme cold of Uranus remains one of the great unsolved mysteries of planetary science. In 2004, astronomers observed large cloud formations on Uranus, with wind speeds reaching up to 900 kilometers per hour. In 2006, they also detected a dark spot on its atmosphere, though its cause remains unknown. This could be linked to the planet's extreme axial tilt. Studying Uranus's seasons is challenging because reliable atmospheric data has only been collected for less than one Uranian year, 84 Earth years. Still, scientists believe seasonal changes are occurring. It is thought that Uranus experiences only two seasons, summer and winter. Each season lasts about 42 Earth years, or half of a Uranian year. So far, Uranus remains a world full of mysteries. Only Voyager 2 has flown past it back in 1986. In 2009, a proposal was made to redirect the Cassini spacecraft from Saturn to Uranus, but it was canceled. It would have taken Cassini about 20 years to reach Uranus. Today, scientists are working on future missions that could send new spacecraft to explore this distant ice giant.
Neptune. Neptune is the 8th planet in the solar system. For many years, this planet has remained a great mystery to scientists. Research shows that the gas and dust that formed Neptune were not especially abundant, yet the planet has a very large mass. It is estimated that Neptune has about 17 times the mass of Earth and a radius about 3.88 times larger than Earth's. Neptune is very far from the Sun at a distance of 30 astronomical units, or AU. It takes Neptune about 164.79 Earth years to complete one orbit around the Sun. One fascinating fact is that Neptune was the first planet discovered through mathematical prediction. Scientists noticed unusual perturbations in Uranus's orbit and used calculations to predict the existence of Neptune. This same method has since been used to search for other objects beyond the solar system. Neptune's weather is characterized by extremely violent storms, with winds reaching speeds of up to 600 meters per second, nearly supersonic. Seasonal changes can also be observed. In the southern hemisphere, cloud bands grow larger and more reflective. This phenomenon was first recorded in the 1980s and was predicted to last until 2020. Because Neptune's orbital period is so long, its seasons last about 40 Earth years each. Neptune is known to have 14 moons. The largest of these is Triton, which contains about 99.5% of the mass of all objects orbiting Neptune. It is also the only spherical moon of the planet. The closest approach to Neptune was made by Voyager 2 on August 25, 1989. Since Neptune was the last giant planet visited, mission controllers decided to direct the spacecraft past Triton as well. Voyager 2 measured Neptune's tilted magnetic field and found that it is offset from the planet's center. However, because Neptune lies so far from Earth, no additional spacecraft have been sent to explore it since. Scientists hope that in the future, new missions will be launched to study this mysterious ice giant.
As we drift away from the last planet at the edge of our solar system, the journey may end here, but the wonders of the universe have only just begun. Every star, every shadow, every unanswered question still waits to be discovered. If tonight's exploration left you with a spark of curiosity, share your thoughts in the comments. Which world fascinated you the most? And if you wish to continue this voyage through the endless cosmos, don't forget to subscribe to Space Exploration and ring the bell. Together, we'll uncover the secrets that lie beyond the stars.